So, arrays and collections. Well, let me sit down. First thing, we'll talk about what an array is. Well, what an array is a stack of data that's all the same kind of thing. Okay? So you could have an array of ints or an array of strings, whatever. It's an index set of the same type of data. Could be any primitives or objects, or you can even have arrays of arrays. So, indexing, which we've been introduced to with strings, right? Basically every string has an array of type char. But it's private to the string, so you can't go in and look at it. The string object itself can, but we can't. But rest assured, every string object has an array of type char. So we've already seen arrays. Now, as far as indexing, every element of an array has an index, the number of the thing in the array. And this makes it possible to not have to distinctly name every element. And it also makes it very easy to loop through arrays. Like if you want to scan an entire array, say, hey, find me this thing in the array, it's very easy to do that. Okay. So, first of all, to help you understand why arrays are so wonderful, let's talk about what you'd have to do without arrays. Suppose you have to include 3 objects of the same type in your class. If you didn't have an array, every one of those things would need a distinct name and would need distinct references within the code. For example, if you wanted to see if any of those 3 objects had a particular attribute, you would have to say if A equals whatever, or if B equals whatever, or if C equals whatever. Your program would have to have that hard-coded in. So, problems arise with that, right? If there's only 3 objects, that might be manageable if the program's not big. But what happens? What if you don't know how many objects you need, right? What if you know you need a bunch of objects, but you don't have a specific number? It's hard to code that in. What if objects are dynamically created or overwritten as the program runs? Again, this creates a big problem. What if there are many objects, not just 3? Well, then your lists of if comparisons suddenly are going to get very, very long and cumbersome to code in. So you don't want that. No. Okay. Now, an array is actually a special type. It is its own distinct type within Java, and I guess we don't really have to worry about that too much, but somewhere in the back of your mind, remember that it is. It's basically an object type. What it is, in effect, is an object with a set of same type data members. Okay, so unlike objects, the array has a length attribute that holds the number of array elements. We've seen with string, if you want to find how many characters long a string is, you call the length method. But with an array, you can just read its length attribute. So if you have an array called array, you get its length just from reading array.length. Okay, so remember for strings, right, int length equals, word.length, where word is a literal string. And here, length equals 4. If you want to see how long an array is, we could do something like an array of ints, new int of 4 characters, or better yet, let's do it with chars. Okay. If we want to find out how long that array is, we just read the attribute array.length. Okay, so int length equal, and again, length equals 4. Okay, so with strings, remember we call this method the length method. With an array, though, if we want to find its length, we just read its length attribute. Okay. Now, every array has the following specifications when you set it up. You have to give it a name and a type, and if you actually create it, you have to give it a length. So, syntax examples. Yeah, when you first, well, it's a little bright up there, isn't it? Let's get rid of that. Oh, better. Okay. When you declare an array, you have to specify with the square brackets what the size is. Okay? And if you don't put in a number for that, then you haven't created it. That's okay. So, 2 ways to do it. You can put the square brackets after the type, but before the name, or you can put the brackets after the name, but also after the type. Reason is, right, unlike most things in Java, almost everything in Java is super specific about how the syntax has to be. But back in the day when Java was being introduced, it's comparable in many ways to C++. The coding in it looks a lot the same. And people who were switching from C++ to Java, well, they had problems with this because, as I recall in C++, this is the way you have to code it. There, you have to put the array after the variable name. But what always made more sense to me is I want to say, this is an array of type int, so I'm going to put the square brackets right after the int, and this becomes the whole type, and then the name. Anyway, if they didn't let that thing happen, if they didn't, Java wanted to do it like this, but because of C++, basically said, we'll let you do it C++ style too, because back in the day, 25 years ago, the IDEs were not very good. They weren't good at finding errors for you. They just tell you there was an error. And it was kind of awful to have to go through and, dig for bugs. So that's basically the reason why there are two different styles permitted for array declaration. Anyway, so when you create it, you specify the size. So an array is specified by square brackets after the type and includes a size. Like down here in the example, numbers, right? So I've already declared numbers. Numbers is an array of type int up there. And so the IDE knows that that's what numbers is. And then I'm going to tell the IDE what kind of array exactly numbers is. Well, it's an int array with 100 indexes, right? So an array of 100 type int variables. If you don't give it a size, then it's null, just like an object that hasn't been created. So up there, the declaration, int numbers, that's just going to be null if I read it then. Once I've created it, then I have an array of 100 ints. Does that much make sense? Square brackets, number indicates the size. This is how you declare and create them. All right. So, another thing you can do, create arrays of arrays. In Java, the interesting thing about that is each of those arrays can have a different size, and we'll talk about that eventually. So, in a sense, there aren't any multidimensional arrays, really. They're just arrays that contain other arrays, but that's what people call them, multidimensional arrays. So, again, same shorthand declaration, right? You can break up the brackets any way you want. You can have them both after the type. You can have them both after the name, one after the name, one after the type. However many sets of brackets there are, you can sprinkle them around however you want, and Java doesn't care. Okay. However, there is one thing worth remembering. If you have a multidimensional array like this, you can't create a secondary array unless the first one already has a size. For example, if I say numbers, right, is a two-dimensional array, I can give an array size to the first one and not to the second. Basically, I said, well, there's 100 arrays, but I'm not going to tell you what the size of any of those second arrays are. Okay? This just says, I have 100 null arrays, basically. But this second one, where I have, again, two-dimensional array, I'm not giving a size to the first array, but I am giving a size to the second one. I'm saying, this would say, because it's not valid, it would say, I don't have an array here, but if I ever get around to creating one, each of those is going to have 100 elements to it. Okay? Java won't let you do this. This is bad syntax. This is good syntax. Okay. Now the shorthand code, you can create rectangular arrays. In a rectangular array, the idea is every array has the same size. So, for example, if I go here to Notepad and I say int data equals new int, okay? This means I have 100 arrays of size 5, okay? That's not a rectangular array. Rectangular array, right? Well, in a sense, it's not a square one, okay? 100 arrays of size 5. And all of the arrays have the same size. So that's a quick way to do it. But often in real life, there's not a good reason to have all of those arrays be the same size. So, for example, suppose you have an application where you're tracking transactions and purchases, right? You have a set of invoices. So you have some array called invoices, and it's a type item, and every invoice contains a list of items that people have bought, okay? So, however many items you have, or however many invoices you have, each one of them, right, is going to contain a list of X items, item arrays. Well, each invoice might have an arbitrarily large or small number, right? So the first, if I have X, it's a little hard to point up there. I'm going to do it in Notepad. I'm going to lift this and just put it in Notepad. Okay. So here, I have X, right, invoices, each being an array of type item. Okay? That's what that first line means. So the array name is invoices. Each invoice consists of an array of items. So the entire thing, right, is a list of items, basically. However, each invoice, as we know from real life, might have a different item count, right, just like we have down here. So here, right, if I say this one maybe has 2 items, or this one has 4, that's perfectly fine. Okay, all the way down to the end, maybe this one only has 1. And that's perfectly acceptable in Java. All we're saying is essentially we have item invoices. Every invoice object is an array of type item, right? But we're just making an extra layer around that. So every invoice, instead of just having, if we just did this, then every index in there, we just have a single item object. But when we do this, we're saying every index in invoice has an array of type item instead of just one. Does that all make sense? Questions on this?
So how to make a multiply item in one invoice?
Oh, well, if we know how many we're creating, right? So let's say we have some method for building the invoice, right? So void build invoice, and we set along some array of items. It would depend on the application, right? So stuff. And we would just say something like an index. Int index times it. And we would just do something like whatever we have from our application. If somebody's bought a bunch of stuff, put it in their shopping cart, bought it, whatever, we figure out what index we need from the array. We pull the array of stuff that people bought with the shopping cart. We call this method, send those two things along, and we just assign that batch of stuff to that index of the array. Okay? Or you could have something that, you just read index like the next open index in your array of items, whatever. Okay? But this would be fairly simple ways to do it. Okay. All right. Or you might do it just calling an item. You might have another method, something like, int index equals get next available index. Okay. This method returns the next available index value. Okay, no surprise there. And then whatever that turns out to be, just assign stuff to that array in the index array. Okay. Now, remember I said way back at the start, arrays are objects. This is true, but arrays are kind of weird custom objects. So, suppose, do this. Suppose you want to track 3 strings in your program. One way to do that is to do that with, within your class, I don't know, words. Okay? And you say string A, string B, string C. And then you have this object, right? If you create an object of class words, then the words object will have these 3 strings. With an array, in effect, that's what you're doing, except you're saying, basically this class array, and then remember they're all the same type, but when you create one, you'll have in effect, string 0, then the string at index 1, then the string at index 2. And this is why you need to give the array a size in order to create it. Because when you're creating this over here, by including the strings in it, you know it's going to have 3 strings. Over here with the array, unless you've given it a size, it doesn't know how many objects it needs to contain in its custom class definition, right? So you have to give it a size in order for this part of the program to be created. That's what's going on behind the scenes in Java. So it's perfectly okay to have an array with a null size. Okay, so if you say int array, okay, then yeah, array equals null at that point. It just is null because you haven't given it a size. Once you give it a size, then it creates this distinct class. So if I say array equals new int size 2, then effectively what I'm doing, class array giving it an int 0 attribute and an int 1 attribute. Okay, and I can create the class definition then. You can't create the array until you've given it a size, and this is why. Does that make sense? Questions? Nothing? We're good? Okay. Okay. Now, both of those cases on the previous slide, right? So we look back here, we had an object, words that had 3 strings, and over there we had an array of words with size 3. In both cases there, the strings are going to be null. We haven't assigned them any initial contents yet, right? They're all going to be null. So, likewise, an array without a size is null. Same thing, right? Because it doesn't know how many elements it has. This is why a two-dimensional array needs to size the primary array first. So think about this, back to paint here. Okay, imagine if we have an array of arrays. So string array, okay? If we haven't created anything there, if we do this, if we say equals new string 1, 0, 1 and 0, that's fine. We can have this class array, and within the class, we can say, fine, there's this first string array, okay? There's 1, basically, and that's okay. But if we try to do it this other way, if we say, don't give it a size and give it 1 there, then we can't create this because we don't know how many things would be here, right? This second one, yeah, sure, every element that we create, it would have 1 string, but we can't write the class definition for this because we don't have this first one to contain it in. Okay? All right. You don't fully, I'm not going to ask you questions about that on the exam, but in the back of your mind, I hope that helps you understand why, if you have a multi-dimensional array, why you have to create the first one before you create the second one. First array before the second array. Okay. Anyway. So that's all about arrays. That's our long preamble to arrays. Next thing, let's talk about indexing. So just like accessing characters in a string, first element starts at index 0, last index in an n element array is n-1. So string of length n, indexes go from 0 to n-1, same thing for any other array. And every array has a length attribute containing how many elements it has. Now, when you want to initialize arrays to some initial value, like give numbers a bunch of zeros or something, very common to do some kind of loop like this. First of all, we create the array as this one, a list of 1,000 words. And for each of those, basically, this has a loop that cycles through everything and assigns it an initial value of the empty string. Although I feel like I'm missing a quotation mark there, so I need to change that. Okay, there we go. Now we have the double quotes. Okay, we'll get to loops in later, back half today. All right. Now, array elements work the same as any other variable. Okay, so if I have, for example, an array of type int, I could say something like int1 equals 6. And if I don't like that, I could, again, int1 equals 8 or something like that. Okay, just like any other variable. If this over here were, I had int x, I could do x equals 6, same thing. Okay. Same thing for objects, right? I can just, with objects, there's different ways you can do it, but the idea is the same. It works the same as objects. So you could create a new object at that location. For example, if I have string array equals new string 1, if I want to change that first one, right, one option I could do, create a new object at that index. So I could say array 0 equals new string word. Okay, that's fine. I could create a new object that way. Or I could reuse a reference, right? For example, I could say word, I don't know, string text equals new string some text. Okay, and I could say array 0 equals text. Again, perfectly fine. I can say array 0 is now going to point to whatever text points to in memory, and they're going to have the same contents. Or I can just make it null. If I don't like what I have there and there's a reason to make it null, I can certainly do that. I can say array 0 equals null. Different ways to change objects. Okay. However, the array structure is always unchanged. You can change stuff that's in the array, but you're not changing the structure of the rest of the array. In particular, the sequence in the array remains the same. So the way you want to think about this, an array of n elements is basically like a file cabinet with n drawers. Okay? And if you change something in one drawer, you won't affect the others. Okay? So there are other data structures that you have access to in Java with the Java Collections framework, where, for example, if you remove something in the middle, the data structure will compress around it. Basic arrays don't work like that. A basic array is just a stack of data of the same type. You can change anything in one drawer without affecting the rest of the array. All right. Okay. We'll do a little time with paint for that. So suppose I have an array, right, with 8 elements. Clearly, the indexes are going to be one through, I can't even remember anything anymore. Right, these are the indexes. Okay. And within each of those, I don't know, give me an 8-letter word. 8-letter word, quick. Quickest. So suppose we have a string, right? So we do something like string s equals quickest. Okay? Then in the character array, right? So we're going to have an array of size 8 with the index, right? Each thing, we have a Q here, and a U here, and an I here, and a C, and a K, and an E, and an S, and a T. Okay? This is what our array is going to look like. And if I say after this, s.char, let's see. Well, I can't change the things in place. It's actually going to create a new one. So if I say I'll do it up here. I'll say text 5 equals A, right? Then what I'm going to do is I'm going to cross out that E here at index 5, and I'm going to replace it with an A. Okay? That's all that. None of the rest of the array is affected. I'm just changing that one value at that one point. Okay. Does all this make sense? We can probably do this. Seems simple enough.
Why you trust A not zero?
What's that? Well, I'm just demoing what would happen with this code. So if I say I have an array like this, why I do it? Well, I'm just demoing how the syntax works and what happens when I do. Yeah. I mean, suppose somebody, for example, suppose I'm doing some text editing, right? And I type over one letter and replace it with another. Somewhere there's an array that's storing that text. So, yeah. But it only affects that one, doesn't affect the rest of the array. Okay. All right. Now, stuff gets a little bit trickier when we want to remove elements. Okay, so anytime you remove an object in place or remove an element in place, it's going to leave a hole in the array. Right? So if I have this, for example, let's do, suppose I have, I'm going to bounce out of all this. Suppose I have a bunch of strings. Okay, instead of quickest, I'm going to do something like, oh, where's a string? Words equals new string. Suppose I have an array of 8 strings, okay? And the first one could be something, second one could be something, right? Whatever. I could just give them numbers as text, because they're all strings. Okay, so each one of these has a single character string. If I say words 3 equals null, then this is going to go away and be replaced with the value null, because there's nothing there. Which is not inherently a problem. I mean, it might be that's what I want. But the problem in many applications is if you just have a big array, and every time you add stuff, you make the array bigger, but every time you get rid of stuff, you just leave that hole in array. Number one, it's going to take up more memory because it's bigger, and number two, it's going to be increasingly time-consuming to sort through it. If you want to scan through it, it's going to take longer. So generally, every now and then, if you have this kind of problem where you have a bunch of objects in an array and you're occasionally deleting them, then at some point you want to compress the array back together. For example, right, a more practical thing, suppose I manage, suppose I have some class of user and I want to maintain an array of all the ones that are connected, right? So some class user that's somewhere defined connections. Every time I add a user, right, I'm going to call some method add connections. Every time I get rid of one, I'm going to call some method delete connection. But basically, I'm going to have a big array full of users, and every time somebody logs in, I'm going to need to add an extra element to the array, and every time somebody logs off, I'm going to delete their element in that array because they're not connected anymore. And yeah, you don't want to have to do that. Okay. So what you usually want to do, right, if you're in a big busy application, you don't want to resize the array every time somebody changes, right? You don't want to do that because that takes a while. But on the other hand, you don't want to let it get big out of control. So a typical rule of thumb for a lot of these kind of applications is you make the array initially about twice as big as it has to be. And the reason is that memory is pretty cheap and you can usually afford to be lavish with it in most settings. If you start bumping up against that limit, right, if it's an unusually busy whatever for your application, you find you need to make your array bigger, yeah, then you double it again is a typical thing. Or if the volume of the array gets to be less than half of what it used to be, if it's mostly empty, like it's 4 a.m. rather, and everybody's logged out of your application, you might leave it as is, or you might actually shrink it down at some point. So periodically, you're going to want to resize the array to fit your requirements. So we're going to try this. We're going to put in some code examples for resizing arrays. Now at this point, there's going to be some loops. So maybe, well, you know what? We can do this. We can skip ahead to the loops chapter, and then we'll come back and do the arrays. We'll do that. Okay, so bear in mind, resizing arrays, this is where we left off, and we'll come back to this. Does anybody have any questions about arrays thus far? Any more stuff? Okay, so the big thing, arrays are a special class of objects. They're basically custom objects. They all hold the same kind of thing. It's all indexed just like the characters in a string. Okay, that's basically the stuff about arrays. Okay, well, we're going to jump over to loops then. Okay, so they call them repetition statements, but I'm old school and we just call them loops, so that's what we call them. So a loop is a kind of code structure that allows the same kind of action to be repeated until there's some condition met for ending it. For example, you might accept user input until you determine that the input is valid. You might initialize a set of array elements, starting at index 0 and going through to the last element. Or you might do some kind of data sorting algorithms that require, a start and a stop point. We'll, time permitting this semester, we will cover some of those. So, Java has 3 basic approaches. Number 1, there is a while loop. In a while loop, there's a test first. You see, if some condition is true, then do these statements in the loop block. After you've done them, you go back and check the condition again. So, while loop has the test first. In a do while loop, you do the action first. You execute the loop block first, then you do the test. If the test is true, then you go back and do the loop block again, right? And you continue repeating that until the test condition is false. There's also a third one, for loop, but a for loop is actually a shorthand for a while loop. It's just a compact, very clear way to write it so that anybody who's showing up to look at your code out of the blue can just look at the for loop and say, oh, this is what that loop does. A while loop tends to be a little bit more convoluted. Okay, so there's really only 2 types. There's a while loop and there's a do while loop, and the difference between them, the while loop, the test happens first, the do while loop, the test happens after. Okay. So, in a while loop, the test condition gets checked first. If the condition is false, you skip the loop block. If the test condition is true, you execute the loop block, then go back and check the test condition again. And this test condition is independent of any code in the loop block, right? You can use different variables, and the loop block code might or might not directly affect whatever's going on. For example, suppose you have some sort of timed operation in your application. You might say while, right, something like this. Okay, while, and there's some method that, okay, so we can have a method that returns a Boolean, time remains, and that'll either return true or false depending on whether time remains. And we could do while time remains do loop stuff, right? Whatever that may be. Okay, so when you first get to that loop, you're going to check the while, check the test condition. If time still remains, fine, do the stuff in the loop. And once that's done, you go back again, call that method, is there time still left? And it's not necessarily true that anything in this loop affects anything over here, right? This is some separate timer, possibly retrieving the time from some entirely separate source, not even from a different computer. All right. So, basic syntax is this. If you have a while loop, first you're going to have the word while, then in parentheses you're going to have some Boolean variable, Boolean expression. And the expression might be a simple Boolean, a literal. You might say while true, in which case the loop is going to repeat forever. Or you might call a method that returns a Boolean value, or you might have some kind of test condition in there that evaluates true or false. Okay? And as long as that while loop, as long as that test condition is true, you do the loop statements. like other things we've seen, like with the if statements, braces can be omitted for single statements. So if your while only has one thing going on, you don't need the block. For example, let's do this. Let's make a code. Make some code. Okay, so on with loops. And we can do a very simple thing here and say while true give it a second, get the lag. We'll print out the number 4 for no good reason. Okay? And as you might guess, this is going to give us an endless batch of 4s. Bzzz, and there it goes. Okay? Is true always going to be true? Yeah. Right, so there's not much to be done about that. Okay. And then this is equivalent, of course, to that. But since it's only a single statement, we don't need to put the braces in. Okay. So, more practical example. Suppose you want to ensure valid input, right? Like you're doing a login process. You say, hey, give me your name, and I'm going to see if you're in the system somewhere. So, we can have scanner input as new scanner system.in. We create our scanner to read user input. We have a null string or an empty string. String s equals nothing. We have a Boolean variable, is valid. Initially, we set is valid to false because we do not assume going in that we've gotten a valid input. Okay. You could make it work the other way, but it'd be a little more difficult. Anyway, we do our test. While not is valid. So is valid is initially false, so not is valid is initially true. So we're going to execute what's in the loop block. So we do our printout. Please enter your name. We're going to read the line. S equals input.next line. Then we're going to say if s.length is greater than 0, is valid is true. Right? Our only criterion here is that somebody has entered in at least one character. Okay? And at that point, we're out of the loop because if is valid is true, then when we go back up to the test, not is valid will be false. We'll skip the loop block and we'll go here to hello, whoever you are. Okay? So we can lift this and put it straight in our application and make it work. Let's do this. I'm going to input you. I'll leave that as a sample. Okay. And we'll call fwl.intro. Okay, so we can run this. Please enter your name. And if I just hit enter, I don't enter anything. I stay in the loop. I'll enter my name, Doug. Hello, Doug. And the program ends. Easy. Questions on this? Does this method make sense? The loop makes sense? Yeah, we're good? Okay. I keep doing that. Okay. So, that's it for while loops. That's it for the syntax. So, do while loops, again, the loop block executes first, and then the test condition gets checked. If the condition is false, you skip the loop, right? You don't repeat it. Okay? Otherwise, again, you go back and you cycle through again. Now, unlike a while loop, the key practical impact, unlike a while loop, a do while loop has to execute at least once because you first do and then you check. The while is the test condition. So, do while loop is always going to execute at least once. Syntax here, do some stuff while the test condition is true. Okay? And again, same thing, loop braces can be omitted if you only have one statement. Okay, so I can do, if I can do the same thing. Do Didn't like that. Oh, yeah, shit. The IDE is smarter than it used to be. Look at that. I don't know if you guys saw. I have an unreachable code statement here. Because the way the program is written, I'm never getting out of this. That's kind of neat. I didn't used to check for that. Anyway, so I can do this. I can do Boolean value equals true. It's not smart enough to catch that, though. Okay. But that's fun. IDEs are advancing all the time. Kind of neat. All right, but if I run this is again going to be an infinite loop where it's just going to zzz for the same as we've seen before. Okay, but we don't want to do that. I'll put in here sample endless loops. Okay. Okay. So you can make the same thing work, right? Same example we did, but here we're doing it with a do-while loop. So suppose again you want to ensure valid input. Again, we have a scanner, we set an empty string, we have our is valid is false. We do, right? We get the input and we check if it's valid. If it is valid, then we're done. Otherwise, right, if the length is 0, then is valid will remain false. And not is valid, not false will be true, so we'll repeat and we'll get new input. And in fact, there's no practical difference at all between these two versions of the method. Okay, so I'll do it here in the code. Put in that same code there. What doesn't it like? Oh. I can fix that in the slides too. Okay. Again, if I go back up here and I do intro 2, I have the same method. Basically, it's going to ask me for, please enter your name. As long as I keep hitting enter and not entering any text, it's going to ask me for a new one. And finally, I'll say Joe. Okay. Hello, Joe. Exact same method. Okay. What's the takeaway from this? Well, most of the time, quite often, you can make a do-while loop that does the same stuff as a while loop. It's usually possible. Many problems are you can structure one as either one. However, we'll talk about this for a second. Then I'll jump back to where I was. So choosing between the two. Often either type of loop is possible. In the example we saw, made it work with a while loop, made it work with a do while loop, exact same code. But bigger picture, when you're coding, you can have a choice of things to optimize. You can optimize how much memory you use, you can optimize how fast the program runs. If you're doing like gaming type stuff, right, where it's like cutting edge graphics, then yeah, you want to basically be lavish with use of memory and say, don't even bother buying this game unless you got 16 gigs. But you want to have it run really fast. And there's some correlation there that if you have a lot of memory available, you can make the application run faster. But for a lot of business programming, you're not so worried about that. You're not so worried about having the program be super efficient. What you want to do is have the code be easy to write and easy to maintain and have it hard for there to be bugs in there that you can hide. Actually, in a lot of business programs, simplicity is a great virtue because you write a program that won't fail, that won't crash and bring everything down. So, quite often, this is what you optimize in real life. So, good practice. Think about the easiest way to model something. If you're getting somebody's name, you're always going to ask for somebody's name, right? There's not a situation where you're not going to. So a do-while makes sense because you're definitely going to ask the person's name first, right? So you're always going to do something. So you probably ought to write it as a do-while loop in the first place, even though you could write it as a while loop. The do-while just makes more sense. You're definitely going to ask for somebody's name. On the other hand, while might make sense if sometimes the loop shouldn't display at all. For example, if you're grabbing a list of query results from a database, sometimes you're not going to retrieve any results, right? So you're not going to build that whole thing in your web page that displays the results. So the while while makes sense because sometimes you're actually not going to retrieve anything. Okay? Yeah. All right, but again, most of the time you can make one or the other work, but so it's not usually a crucial decision, but that's a good guideline. Okay. Now, earlier I had said that the big difference between a do-while loop and a while loop, do-while loop always executes at least once, while loop might not, which is very different from saying that a do-while loop will execute one more time than a while loop. That statement is not true. For example, consider this code, right? I have an initial value of x is 5, and I want to add something to it in the loop block, and I'm going to repeat it as long as x is less than 10. Okay? It's the same kind of code here, right? How many times does the first one execute? Well, x equals 5. I do the do, so the block executes once, add 10 to it, so now x is 15. Is 15 less than 10? No, so I'm done. The loop executed once. Here, same kind of thing, x is 5. I check, is x less than 10? Yeah, it is. So I execute the loop block once, add 10 to it, so now x is 15, go back up. Is 15 less than 10? No, so I'm done. They both execute once, okay? Now sometimes, sure, sometimes a do-while loop will execute one more time than a while, but it's not guaranteed, okay? So, it's not that a do-while loop executes one more time, it's that it has a minimum execution of 1. While loop has a minimum execution count of 0. Okay. While we're on the topic of equivalence, I'll also add this. So, suppose I have represented whatever's in the loop by that comment for loop statements. So, the first one, do loop statements while. So I'm going to execute the loop statements once. It is actually totally equivalent to this. Doing the loop statements once, and then entering into the while loop. And then this, if this condition is true, I keep repeating. So the top few lines there are absolutely equivalent to the bottom few lines there. You can always make a while loop that's equivalent of a do while loop just by including the loop statements an extra time ahead of it. Okay. Do we understand enough about loops that makes sense? Okay, good. All right. Oh, any questions about this? Do while versus while loops? We're content, we're happy, we understand everything? Good. Okay. Well, if not, let me know, because who I really want to hear from are the people that don't. Okay. Now, for loops. For loop is a shorthand for a while loop, and there's 3 components to it. First, there's an initialization, and that's optional. That's where we can do things like set variables, variable values for like loop counters. The second thing in the middle is a test condition, and you always have to have a test condition. Every loop needs a test condition, because that's how you know when it's going to stop. And then third, an optional ending statements, right? So stuff that you want to execute after the loop is completed. Now, the initialization and the ending, they can have multiple statements separated by commas. That's another case where we use commas to separate groups of related statements. So, the syntax looks like this. The first line up there, x equals 0 and y equals 1, those are your initializations. We're setting those values to those initial values. The test condition is the third thing, x is less than 10. So as long as x is less than 10, we're going to repeat the loop. And then last, increment x, increment y. Okay, we're going to increase them both by 1 at the end of the loop. So, what this loop will do is it'll start off, x will initially be 0 and y is 1. We'll print out x, and then we'll print out y squared. Okay, so where's this? X plus y squared. And y squared will start off as 1. All right, so I'm gonna lift that text and put it in here. Void loop demo. Okay, if I want to do this, here it is. Get rid of that. Update the slides. Okay. Right, here I am. So if I'm doing this one, I'm going to not do intro 2 anymore. Now I'm going to do, what was was the name of that method? Loop demo. There we go. Okay. So I run this, and it's going to print out all those numbers. So I just, boom. Okay. Start off with 0 and 1, then 1 and 2, then all the way down to 9 and 10 squared. So that's what the loop does. Now the nice thing about a for loop, I can very easily look at that top line there and say, ah, here's the initialization, and here's when it stops, and here's what I do at the end. So a common structure to do for something like this, if I want to initialize a batch of, if I have an array, so say string array words equals new string, I have 10,000 strings I want. If I want to initialize them all to nothing, I can do for index equals, or int index equals 0, and do it while it's less than words.length, and then index plus plus. And for each one of those, I'll even, okay? And anybody who's been programming for a while can look at this and say, oh, yeah, here's a loop where I'm starting off at 0, I'm doing it for every element in that array. At the end, I'm incrementing index, so I start at 0 and go all the way through to the end. And then at each iteration of the loop, I set that particular string to an empty string. Okay? And that's what makes for loops a little easier than a while loop. The equivalent while loop would be something like while, right? Words, well, first you'd have to do this. Int index equals 0, while index is less than words length. And then you'd have to do that. And the pieces that you're looking for, they're all there, but they're scattered around a little bit. Okay? So the for loop is just a quick, easy way of putting all that information together for how the loop is going to run. And that's why it is. But it's just basically a shorthand for a while loop. It's the exact same stuff. Works the exact same way as a while loop. Does that make sense? We understand the equivalence here? Yeah? Okay. All right. Now, there are some quirks. Okay. Number one, any variable declared in the initializations, they have their scope limited to the loop block. So I'm going to show you. It can lead to some weird things. So over here, for example, I've made this. Int x equals 0, y is 1. So I can do int x equals 1. Which should look really weird, right? Because here I'm double declaring a variable in the same method. But basically, as far as Java is concerned, this is kind of like a method within a method. It's its own separate thing, and the scope of these declared variables, they don't go past that. Okay? But here, if I put this up in front, Java doesn't like that because the scope of this is the entire method, not just the loop block. So when I see that, Java looks at it and says, oh, you've double declared x. Let's start here. Okay? All right, so that's one quirk. And it's a way that you can declare the same variable twice within a method, or more than twice. I can have multiple loops that all use the same variables. Okay. The other thing looks a little weird, but if I want to, I can omit the initialization or ending statements. For example, go back to my content here. Another way I can do this, I can do int index equals 0 for empty semicolon and an empty one there, and then same thing, words index equals nothing. Right, actually, I have to put in the I can do that. And it's exactly the same thing. This is same as this is same as this. Okay? All three of these code snippets, they all do exactly the same thing. They run through the same loop. Okay? Yeah. Is what? What would what?
You said the three loops are the same, but the second one didn't declare that the index is start from 0.
Oh, well here I'm doing it as an initialization. So Java understands that this happens before the loop even begins. Here, I'm doing it before the loop begins, but I'm just taking it out of the loop header and putting it as a separate statement before the loop. Same as I'm doing over here, separate statement before the loop. But the point is, whatever I put here, this doesn't repeat. This happens once before the loop starts. Okay, good. All right, and the same thing. This is the test condition in the middle. Every one of these loops, they have a test condition. Again, it looks weird the first time you see it, like why do I have these floating semicolons? But you're just letting Java know, for the initialization, I'm not doing anything. And for the closing statement, what happens after the loop, I'm not doing anything. Okay? In this case, the incrementing the index is actually happening as a separate statement included at the end of the loop, just like it is here. Okay. All right. So those are the quirks. Now the syntax, let's see. I feel like if I'm using an old version, it must have some other bugs. Incrementing is common, right? To close out those loop statements like we did index plus plus, that's a very common thing to do. You start at 0 and you increment it each time so you can access each individual element of the array. It's very common, but any other variable change or in fact any other statement can also be included. For example, here we start off with some string. We're doing a for loop, so x is 0, y is 1. We do it while x is less than 10. And at the end, we assign the value of that whole string, that text string of x and then y squared. We assign it to s and then print out s. And then instead in the loop, we execute these. Okay, now the difference is, the way this loop is written, these increments happen before this closing statement. So our old one we started off with x is 0 and y is 1, and we printed that. If we do it with this one, we're going to start out the other way. Then this happens first, and then the closing statement. So we'll start with x is 1, go down at the very end, it'll be x is 10, and y squared is 121, 11 squared. Okay. Does that make sense? That whatever's in the loop happens before the closing statement for the loop. Because when we put this thing as the third spot in the header, we're saying all this stuff happens after anything in the loop happens. It happens with every iteration of the loop, but it happens afterward. Okay. Now again, examples commonly used to initialize arrays. I guess that line's in there. Sometimes I cover loops before arrays. This semester I'm not. But here's another example. Suppose you want to account how many instances of a particular substring occur in a big string. For example, suppose you have some giant array of text, right? You've converted a textbook into data, and you want to read from it how many instances there are of a particular, you're searching for somebody's name in the textbook, whatever. So, you have some string text. Text is the entire slug of text you're looking at. Sub is the particular string you're looking at. So if you're doing like a search, control F search for something, you're looking for somebody's name, then sub would be that name that you're looking for. Initially, you're going to assume you haven't found any. You're going to start at index 0 in the document, and you're going to continue to the end of length minus the length of the substring, right? Because if you have a substring of 10 characters long, it doesn't make any sense to look at, the very last character. You have to look at the last place where there's still going to be 10 characters left. Okay? And then x plus plus. Every time through, you start at a new character. So, say if sub dot equals text dot substring. Basically, if you find a match, then you increment the count by 1. Okay? And at the end, however many counts you find, you print them out. So this is actually just a single statement. You say, if blah, 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 then increment the count. Even though it's multiple statements, when Java sees it, is going to look like, right? Okay, let's increment that. And then same thing, this if, since there's only one statement here, I don't need braces around it, but I can put them there. That's what's going on. Okay? All right, so you can scan through things, even if you haven't considered arrays. We just have a big string that actually contains an array. You can do that. Okay. Questions on that? For loops. That's for loops. Okay. Those are our three types of loop: while, do while, and for. These things must be understood. Okay. Now, there are a few more some of it is general purpose for loops and some of it's specific to Java. So, first thing, after the loop is done, any conditional test variable is going to have the first value where the test is false. For example, we start off with x is 2, we continue while x is less than 256, and we multiply x by 2 with each iteration of the loop. When we get to 128, we're going to do the test, say 128 is less than 256, we're going to do the loop again, multiply it by 2, x becomes 256, we do the test, and it's false. After the loop, x will be 256, not 128. It's a very common mistake people make, that assuming that, oh, if I have a loop that counts from, 1, 0 to whatever, at the end it's going to be, 1 less than I think it is. But no. It'll be the first value where it was false. So likewise, simple example, I'll just do this here. Oop. Oh, I have to do this first. Okay, when we run this, okay, each time I'm incrementing, the last time the loop is going to execute, x will be 9, right? Because once I increment 9, then x equals 10 and I'm out of the loop. But at that point, x will equal 10. So if I run this, boom, final value of x is actually 10. It's not 9. It's not going to be the same as what's in the loop. Okay? And that's one thing. Other stuff. Rule of thumb, generally loops should progress toward completion every time they iterate. Increments and decrements are strongly preferred. Inequality tests are dangerous, especially for doubles, especially for floating points. For integer types, they're not so bad. But the risk is always that somehow the loop will not end as you intend. It ends up caught in an infinite loop, and that is a big problem for many applications. So, for example, let's run this one. And you can see what happens. Okay, so this one I start x is 0, x is less than 10, x times equals 1, right? Obviously this loop will not progress toward completion. Every time through, I'm going to multiply x by 1. So what's 0 times 1? It's always just going to be 1. That loop is never going to end. But this one, right, so that's not very interesting. But this one is more interesting. So here I say, I'm going to start z as 0. I'm going to continue the loop as long as z does not equal 10. And each time through, I'm going to add 1/7. Well, sure, after 70 iterations, I'll have added 1/7 70 times, and it should equal 10. Well, floating points, Let's see how that goes. Nope, we never hit the number exactly. Okay? Yeah. You get the idea. Zzz. Yeah, that went pretty quick. Okay. So, floating points are dangerous. Equality tests are dangerous. The better thing to do is while z is less than 10.0. Okay? And then we run it. Boom. And it stops. Because we can see, right, even though it gets real close to 8, it's not exactly 8. Right? Even though it gets really close to 9, right? Or it gets really close to 10, it doesn't quite hit it. Okay. Number 3. Same stuff, inequality testing with floating point types is difficult because there's always going to be that kind of rounding error, right? So the best way to do it is to include a margin of error, in particular with a float, right? So I can lift this bit of code. Floats, remember, only keep 7 or 8 decimal places worth of data. So if I run this one, each time through, I'm adding 2/3, but if I would think if I add exactly 2/3 enough time, it should eventually hit exactly 103 starting from 1, but it doesn't. Zoop. Instead, it gets really close, right? There's only a few decimal places here because I have like 7 numbers to actually keep in there. The last one's a 0. So after the loop goes, I get this, which is perhaps not what I intend. So the better way to do it is like this. Use a margin of error. Okay? If you must do this sort of thing, float x equals 1, and I say, as long as x is not outside this range. I know I'm not going to hit 103.00000 exactly, but if I'm really close to it, then fine, then it can be done. Okay, and this one will actually hit 103, right? It gets real close after loop boom. So when I add it, it gets close enough that it says, okay, this is where I stop. All right. Now, while we have this code up here, does anybody see anything that looks really weird and wrong about it based on what we know about numbers to this point? There is something with numbers about this that violates the laws of syntax as we have learned them thus far. Let's take a minute and play the puzzle game. I'll give you a hint. X is a float. That's what you should be focused on. X is a float. What's that? What about the double? What about which double? So you remember this situation, but perhaps not the answer? I don't know. Yeah. Sort of, but you can have floats go out that far, but you're starting to get on the right track. There's a problem with what we're doing with the float. What are we doing with the float that we should not be able to do with the float? Yeah, we're adding a double to the float, right? And we're storing the result in a float. That's wrong. You can't do that. You can't say something like float x equals 1.0 f plus 2.0. You can't do that. Okay? Likewise, can't do that. Same reason, but that's exactly what we're doing here. Freaky, huh? Yeah, Java has syntax problems. Just saying. Okay? There are certain things you can get away with within the scope of a loop header that you can't otherwise. All right, if I do this, it lets us do that. That's weird. Shouldn't be able to do that, right? But it lets us. All right. Anyway, just saying, there's quirks in the syntax. It takes a while to get used to stuff. But that's why I don't test too heavily on the quirks. But they're in there. You may see things that, hey, how can I do this? This seems wrong. But you can. All right. Last thing. Beware the overflow. So, for integer types, right? if you overflow, if you give the number a bigger number that it can hold, for example, if you have a byte that, you can do this comparison. So byte B equals 120, I'll just do 0. Okay, for B, well, we're not going to do, B is less than 128, and we'll say, okay, we can do this. We'll even do, well, what's going to happen? What's going to happen when B gets to 127? And we add 1 to it. It flips around to negative 128, okay, because we set that 7th bit. So we run this, and we end up in a nightmare world of never getting out of this, okay? And we have negative numbers. That was not our intention. If we had been better programmers, we would have seen this coming, but we weren't, so this happened, okay? That's the overflow with integer types, and it can happen with any of them. It'll just have to be bigger numbers. For example, I could do short, and while s is less than, what, 32768, and then s plus plus, and print out s. Same thing. Once s hits 32,767, I add 1 to it. It flips around to negative 32,768. Same thing, right? Yeah. If you programmed back in the day, you knew all these multiples of, 256 and stuff. They were handy to know. Now, not so much. Okay. So, with a floating point type, though, any number that gets too big, it gets stored as plus or minus infinity. For example, if I do this, I remember the biggest number that a double can hold is about 1 times 10 to the 308th. So if I include that, if I make a bigger number than that in my code, so I start, double D is negative 1 times 10 to the 308th, and I multiply it by 10, it should be, right, mathematically, it would be negative 1 times 10 to the 309th, but that's too big to get represented in Java, so instead, we get negative infinity. We get, a number so big that Java just quits. Okay? All right. So that's how floating points and integers crash differently. It's not technically a crash. Your program will still run, but it's not very useful to have a number as infinity and try to do math with that. Just like, if you intend for your loop to stop at a certain point, it's usually not very useful for the value to flip around to 0. Okay? All right. Questions on any of this stuff? This is loops. No questions? All right. All right, well, that's it for loops. We will return to our arrays then. So, resizing arrays. So like strings, remember that strings were what were called immutable, right? We can't just change the elements of a string in place. Anytime we try to change a string object, Java will actually create an entirely new string object at some new location in memory. Same thing with arrays. You can't expand or compress them in place. You can change the contents of the array, but if you do something to make a new array, to try to resize it, add new elements, Java is going to create a new array somewhere in memory. Now, arrays are objects, so they can reuse references using the equals operator, same as anything else. So keep that in mind when we do this example. So the simplest approach to resizing an array is, number 1, create a new array of the same type, but with the desired size, either bigger or smaller. Then, whatever elements you need to copy those elements from the original array to the new one using a loop. Last, have the original array point to the new one. Okay? So, increment example. So here, I'm going to copy this code. I'm going to put in a new class from with arrays. But not very much fun. Okay. All right. So, our goal here, we want to rebuild an array with an additional element. Given some array of type int called numbers, we want to add a new element with a new value n. So that's what we're sending here. When we call size plus 1, we're sending along the array, and we want to add another element to it with the value n. So, first thing that we do, create the new array, numbers2, with one more element, the numbers. Okay? That's what we're doing here. We're saying int numbers2, int array numbers2, is going to be a new array, and its size will be the length of numbers plus 1. It'll have one more element than numbers does. Okay? Second thing, copy all the elements from numbers to numbers2 in the same indexes. Okay? So, one at a time, this is what we're doing, right? So for every element in numbers, we're saying numbers2 at that index equals numbers at that index. Okay, so we're just writing, initially numbers2 isn't going to have any set values, so we're going to copy them over from numbers. At the end of this, numbers2 will have all the values that numbers does, plus one more empty spot at the end. Then, add the new value n to the last index of numbers2. Note that numbers2 dot length minus 1 is equal to numbers dot length. Okay, because numbers2 has one more, right? Numbers dot length is equivalent to numbers2 dot length minus 1, because it's one bigger. And then last, this method will return the new, larger, updated array. Okay, so for example, I might say numbers equals size plus 1, numbers, and new value, whatever the new value is. I'm calling this simple method call. Okay? Whatever numbers is, I want to assign it whatever array this method returns. And so basically numbers2 is going to replace numbers. Does this make sense? This is how you would increase an array. Now if you say, I want to do more than just one, right, I want to like double it, you might say times 2, for example, and then copy what you need to and keep track of the first available index in that array. But here we're just adding one more value to the array. So we're keeping the array compact. Yeah? Yeah. The first one is up here. Loop equals 0. That's the initialization. Yeah, so I set the loop counter to 0 because when I run this, I want to start at 0, and I'm going to keep going until the very end, right? So for every, yeah. Okay. Is this, other questions? This is how you expand an array, make, room for new values. Okay? All right. Other thing, I don't need you anymore. Decrementing, right? Deletion. This is more complicated a little bit. So our next goal, we want to rebuild an array after deleting something in the middle. So let's do a picture. Suppose, good, we still have this. Suppose instead of getting rid of that index, right? Okay, good. Suppose I want to delete the object at index 4. How would the array look? Well, what it would look like is first I would have this. Okay? And then I'd have this in a sense, but the values would be copied over. Okay, so I'd have this. Well, wait, we're not done yet. People laugh at my pixel precision, but it is important, even if it's difficult. Get it, one more. About to give up. There we go, wonderful. Okay, now, all of these things are going to go away. We're going to copy and paste them back over. Okay, instead, these, right? These are what we're going to have at the end. Okay, perfect. This is what our array should look like at the end, right? This one, I'm going to draw the lines, right? This one goes to here, this one to here, this one to here, this one to here, to here, to here, to here, and gone. Okay? That's how the array should look. Well, how do I do that? Well, clearly, up until the deletion point, I copy all of the elements from the array. After the deletion point, I copy one higher index into a lower index. Okay? Makes sense, right? Okay. And then once I've done that, then I don't have to worry about any of this other stuff. So, let's look at the code. Oh, just wanted to grab it. Okay, so I'm going to put this in my... Okay, so again, sample method call. Okay, again, I'm going to compress. I'm going to remove the element at index S, and I'm going to have the array numbers equal to whatever array this thing returns, this method returns. So, how will the code work? Well, did I leave a space? No, I didn't. Okay, so I won't leave a space there. So, the first thing, number one, create a new array, numbers2, with one less element than numbers. Okay? One fewer element. Okay? Yeah? That's easy, because that's what the new array is going to look like. Second thing, two-phase copying. First phase, copy every element before X to same index in numbers 2. Okay, so that's what I'm doing here. For each of these, start at 0. As long as that loop counter is less than X, I'm going to copy that in. So I'm going to say numbers 2 loop is equal to numbers loop. I'm copying them over in the same index positions. Second phase, copy every element after X, because I'm not going to copy X, to one lower index in numbers 2. Okay? So here, for every element in loop, I'm copying it into the index, or every element in numbers, I'm copying it from loop to index loop -1. Right? So just like in my picture here, I'm copying index 5 to index 4, copying index 6 to index 5, and copying index 7 to index 6. Okay? Then, copying complete, so return the new array. Easy. Does this make sense? At least when I'm talking about it? Questions on this? So basically, I'm just splitting that into two parts. If I'm deleting from index 4 here, I go up as long as the loop counter is less than 4, I copy stuff into the same index in the new array. Then I start at x plus 1, and x plus 1 I copy into x, X plus 2, I copy to X plus 1. X plus 3, I copy into X plus 2 in the new array. Okay? And so on as long as I need to until I hit the end of the array. Any questions? Okay. So, another thing. A few more slides for this, and then we'll do a few practice coding things, and then if people have questions about the exam or other stuff, we can talk. Okay. So, searching arrays. We've seen searching arrays before, like index of. So, often methods are going to search an array for the index that stores some matching value. And the value -1 is often used for a non-match. Okay, like we saw with index of for strings. Reason is, easiest way to start is with an index of -1. We say, okay, I didn't find anything, right? Because -1, it's a simple number and it's never going to be a valid index. So if I initially say int index is -1, I scan through to find what I'm looking for. If I find a match, right, I return the index where the match was found. But if not, I just return index at the end. I return -1. And this is why methods like, index of for strings, and actually a lot of other searching methods in Java will use that -1 to return a non-match incident. Okay. Now, related classes. Many people don't like futzing around with arrays and trying to make them work correctly. They're a bit of a hassle. They often work faster than some of these macro type classes, but still, again, optimizing how your code runs versus ease of coding. Many people like these other ones from the Java collections framework. So if you're interested, in particular, ArrayList is one that seems to be very popular with the undergrads. Basically, it simplifies a lot of these things. You can add elements to an array list, you can delete them from an array list, and it handles all of that compression and expansion for you. It's just also a little bit slower. And you don't have that easy framework to say double an array only when you need to. Something like ArrayList, every time something changes in the array, every time an object gets added or deleted, it's going to change the size of the array, and that can be a bit of a hassle in Java. So it's not necessarily going to run fast. It's probably not going to run very fast by comparison. Okay. Now, we had a search thing here. I don't know. I'm not going to worry about this. I'd rather just give you guys some code practice. But if you like, you could try this if you don't have much going on in the next couple days and you want to, I used to do this as a game for basically doing like a binary convergence algorithm. I have some code from one of my previous semesters where I could show that. But instead, I think today we're going to go to coding BAT. Okay, last call for questions about any of this stuff. Intro to loops, intro to arrays. All right. Well, I'm going to shut down the recording.